we have covered, all right, we have covered GAS last week. And just to do a quick recap, I'll share with you what Google Suite is all about, how we can then do automation using Google Apps Script. But we don't want a standalone apps. We have learned how to extend to a web app. And by having it as a web app, we can now connect through the internet to trigger the web application. And for us as IoT, we are interested in storing data. Therefore, we look into how to use Google Sheet API, how we can insert, how can we open our workbook, and so on. Okay, so this is what we have looked into. And I will now quickly jump to our topic where we are going to talk about cybersecurity. So before I go into greater details, I want to share that for IoT or for cybersecurity, this maybe for the next 1 hour, I can only or possibly scratch the surface of the iceberg to share with you some of the things within cybersecurity. But that 1 hour or less cannot make you a cybersecurity expert. Okay, what I'm trying to do is to give you some exposure to let you understand what is or how things are handled over there in terms of security. Now that we are also talking about secure connection to Google server and so on, why do we want to go through the hassle? Why are things or some special arrangement like redirection of URL and so on? Okay. So with this disclaimer, let's move into the topic on security, right? We will look at how data are transmitted. So as part of the understanding, followed by how we can perform authentication. How do we know we are the right person to gain access and so on? After which we will then look at some basic encryption. This is hopefully will be fun for all of you to try out, right? How you can then encrypt messages and so on. Then after basic knowledge about encryption, we will move into today's standard in terms of internet connectivity. What kind of security do we have in place in modern internet data exchange? And then finally, when we move on to Industrial 4.0, what is the key concept that each and every one of us must have in order to stay secure and stay safe in this cyber era? Let me see. Do I have any? Okay, don't have. Can I just get a quick survey? Anyone can tell me if you recognize where this picture was taken? Or can you see or notice any special thing within the picture that you can identify? Can you write in the group chat? Pardon me, I didn't set up. Okay, very good, Royson. Yes, it's in Korea. Some more? What else? Seoul Tower. Good. Location has been nailed down. What can you see in the picture? What can you see in the picture? All this. What are all this? Locks. All right, multiple locks and so on. And of course, those who have been there, probably you will know, all right, why people would buy locks and then lock it on the fence or the fences at this particular location. And I thought this is a good starting point to open up this topic on cybersecurity. And the reason why we want locks in this particular case, in this tourist attraction point, is that couples would like to lock down, okay, or clamp down okay, clamp down is a wrong usage. They want to lock in their relationship, right? And that's why they will do such a thing. But when we come to cybersecurity or in any security in general, the question is whether a single lock is sufficient, right? Or as one of you have typed in the group chat, do we need multi-lock, right? In today's context, some of our homes, right? Most homes or most HDB flats have a metal gate, all right? And then you have a wooden door. So minimally, there will be 2 locks, right? One for your metal gate and another one for your wooden door. But are the 2 sufficient, right? Similarly, some of you may be paranoid. Okay, not not targeting to any one of you. I'm just saying that there may be a person who is paranoid about safety. He may implement many padlocks at the metal gate, and then there are some other locks for his wooden gate and so on. So a lot of time when we look into security, it is, I would point it towards a social problem, right? Imagine a society that is safe, that is trusted. Do we still need lock? Do we need to close our door? Right? Like some of you have heard about kampong spirit. So in the past, in kampong, there isn't any gate that is locked. All their gates are open, doors are open, free access because of the culture and the trust that we have. Things have changed quite a bit, right? And nowadays, even in cybersecurity, they coin a term called zero trust, right? When they say zero trust means that whatever they are dealing with or interactions or sharing of data, the first concept or the first thing that comes in mind is zero trust. You cannot trust anyone. Therefore, how can you stay safe? And these are things that is moving along because of bad things that have happened, and therefore it become quite troublesome, especially bringing back the case of multiple locks for a home. Imagine you have 10 locks. Just to enter your house, you have to unlock 10 of that padlocks to go in. And when you're in, you have to lock back the 10 locks. So in a way, it is troublesome, all right? But sadly to say, for a burglar or a thieves who would like to break into your house, the bad guys don't follow rules. They don't come in from the front door. They often come in from the back door. Right? So let's not overdo it, because when you try to protect anything, things that dearly to you, you want to protect as much as you want. But as I mentioned about the burglar or the thieves coming in, they don't go through the proper channel, right? They will come in from other means, and this is where we have to be careful. All right. So in terms of internet, all right, why are we so mindful about this part of the cybersecurity? This is because on the note on data transmission, right? For data transmission, for the past weeks, you have been seeing, or you have been doing it, exchanging data through the internet using devices like your handphone, your MKR, and so on. So when we do data transmission or exchange, it can be various forms, right? It could be wired, it could be wirelessly, and both are equally vulnerable. For wired, people can tap wires. They call tap wire or wire tapping. Means they clamp or clip some connection to the communication wires like our telephone lines and so on. When it comes to wireless, then it is even easier because it's all through the air. As long as you have an antenna, you can receive the information. Then people can actually tap on those signals. With regards to network, all right, just now, in fact, I am still in NYP. I'm using the school network. Somehow it could be a router refresh. It could be my laptop. But if you find that my voice or the images is breaking out, please let me know. I'm not sure whether the corner that I'm in now is having a poor reception, or is there really a third guy trying to intercept my signal. Okay, but you have to be mindful about the three different networks. All right, first one at home, private. Usually home network, it is not very secure, because when you set up smart home, all your gadgets get to talk to each other. And how many of you really manage your home Wi-Fi router, right? How many of you look into the details? How many of you are familiar with resetting password and so on? So this part, I'm talking about in a very general basis, that most homes network are not very well protected because of lack of knowledge. But when it comes to work or school, of course, there are delegated staff, IT staff, IT personnel to look after the network in school and at workplace. There's another type of network which is public, where you go to coffee shop, airports, and those public network is a place that we really have to be very, very careful. Especially you join network that you don't know who's the owner, and you don't know who is looking into all those data. Okay, so sharing with you these three names is because whenever you join a network, your laptop will probably prompt you, all right, select which type of network, and the system usually would have some form of level check on what you should be doing and give you advice. We have also looked into the word sharing. When we set up our ThinkSpeak channel, we try to share with everyone. When we talk about sharing, there are a few different type of sharing. Are you sharing so that people can read and open your data? Or are you giving full access so that they can modify, or even write or change data on the document that you are sharing with them? So in terms of privilege or privileges, these are something that you need to take note. Now, when we are in any of this situation, right, there can be a possibility that someone eardrop trying to sniff out packets of information, and this is the part that it is critical, right? We don't want our confidential data, for example, your credit card number, your SSID, password, and so on, to leak out. Therefore, again, it is a practice or a good practice that everyone should have, that no one should have one common password. Why? Because if you have one common password for your credit card, or your home PIN number to access your door lock, the same PIN number for your email account, and so on, when any one of these access get eardrop, then that one password can apply to all right? And therefore, it is not advisable to have common password. And you should come up with ingenious way to have one password, unique password for different account. So during World War, all right, during World War, there is such a machine called Enigma machine that do encryption. And that, I mean, it is an interesting story for those who like to watch movie. You can watch the movie, you can read up books, you can read up how this machine is designed, because they have broken it down. I think in one of the YouTube, they even share the details of this Enigma machine, how they do encryption half a century or more than half a century ago, and mechanical encryption machine. I think that probably would entice or excite you. But in today's context, we are looking at packets of data when we share through the internet, and this is where the TCP protocol comes about, when we send information through the internet. So what is the problem when we send data, right? So of all this that we are talking about, what happened is that when you have your original confidential data, which is the source, if you have encryption, the encryption come with a key. Later during the demonstration, I'll share, all right, how do you really design key or make use of some of the encryption method to encrypt your data, so that this data during transmission, all right, so you encrypt first, encrypt before you send it out. So once you send out into the public domain, so this dotted line refers to the internet, for example, if there's a bad guy trying to open up or read your message, because it is a common platform, anyone can look at the packets of data. When they open up and they realize that it's all scrambled alphabets, then that's where, even though they happen to open the packets of data, nothing is lost, because they cannot make sense of what is those data. Okay, but your end goal is to send the data to the rightful destination. At the destination could be your friend, could be your tutor or your lecturer like me. Then in order for me to know what you are trying to send over, then I have to decrypt. All right, so decrypt is to put the scrambled text back to the readable one, and this is where I have to use the key. Okay, so this is a general idea why we need to encrypt. This is because the common channel, the internet, it is not so protected, because anyone inside the network get to see those data. Just like Modbus, all right, when we send data in Modbus, everybody get to see the data. Why? Because part of the data frame contains the client ID, and therefore everyone must know what's the data. Otherwise, when the slave ID has been called, the device will not be able to acknowledge. Okay, so in industrial context, in the past, most of the industrial network are open. right? So there's no encryption and so on, which is quite bad. But now that we are putting everything up and connected to the internet, then different means of data handling has to be better managed. So coming back to ThinkSpeak, all right, we have the read key, write key, and this is how it adds additional security, right? Because if you have noticed, when you copy the read key, write key, you notice that that string of text doesn't make any sense because they are meant to be unique. They are meant to tie back to your channel ID. Therefore, even when you do a web browser update using ThinkSpeak API, you notice that you don't even need to submit channel ID. Unlike in MKR code, you have to put in channel ID. So how would ThinkSpeak server know which channel ID you are sending when we do it manually? This is because the unique API keys that you make use of when you send over.